Hi, my name is Sankal Kata, and I'm a junior studying health sciences, and I'm an undergraduate researcher in Dr. Sa Lu's lab. Today, I'm going to talk about tetrachloroethylene exposure in Martinsville, Indiana. Martinsville, a town in southern Indiana, has an EPA Superfund site with a toxic groundwater plume contaminated with volatile organic compounds that are also known as VOCs, specifically trichloroethylene, which is known as TCE, and tetrachloroethylene, which is known as PCE. There are several other groundwater plumes in the Martinsville area that are contaminated with similar compounds. Plumes are masses of pollutants from an underground water body that are spreading from a source. The sources of the contaminants are believed to be former dry cleaning facilities. The town has abnormally high levels of cancer that have been believed to be related to groundwater contamination of PCE and TCE. The EPA has conducted an intensive site investigation in the area focusing on groundwater, soil vapor, and indoor air. While the EPA has measured the contaminant levels in the groundwater, soil vapor, and indoor air, the extent and level of personal exposure, such as who and how many people are exposed and the level that each individual is exposed to, are largely unknown. Performing a personal exposure assessment can shed more light on how the exposure may affect people's health in the community. Results from the study would help the city of Martinsville get powerful data on the potential risks to their inhabitants, as well as raising awareness for the city to receive more federal interventions. We conducted this pilot study to explore and extend the level of personal exposure to PCE, TCE, and other toxic VOCs among Martinsville residents. In order to determine the personal exposure of PCE, TCE, and other volatile organic compounds in Martinsville residents, data was collected in 3 sampling trips to Martinsville. The first 2 were on December 7th and 8th in 2019, while the final trip was on January 5th of 2020. During the first trip, we focused on the EPA Superfund site and collected indoor air samples from 9 homes using a sampling canister. Tap water was also collected from 10 homes. These homes were all located in the EPA Superfund site. The indoor air samples and tap water were collected to determine the prevalence of PCE in the surrounding residents. Exhaled breath samples from 22 residents were collected the next day on December 8th. On January 5th, we collected exhaled breath samples from additional 18 residents, including residents living in other contaminated sites and 3 residents who were living outside any contaminated plume areas. This table presents the summary statistics of the results. Our preliminary data showed that TCE was largely undetected. As a result, the focus on chemical exposure was diverted to PCE. PCE was detected in 100% of tap water samplers with a mean of 0.7 micrograms per liter, 66% of residential indoor air samples with a mean of 9.1 micrograms per cubic meter, and 100% of exhaled breath samples with a mean of 6.6 nanograms per liter. Although PCE was detected in all the tap water samplers, it has a very narrow distribution ranging between 0.39 to 0.92 micrograms per liter. These results were detectable, but only semi-quantifiable. While 3 houses had no detection level of PCE, 4 houses had PCE levels above the reporting limit, and 2 houses exceeded the Career Risk Evaluation Guide value of 3.8 micrograms per cubic meter. 1 house also exceeded the EPA removal action level of 42 micrograms per cubic meter. This demonstrates a significant level of PCE exposure in the indoor air. Further sampling is also encouraged because of the small sample size. PCE was detected in all of the exhaled breath samples with a wide concentration range of 2.2 to 44 micrograms per cubic meter. The median of detected concentrations of the individuals living inside the plume was 4.5 nanograms per liter, while the median PCE concentration of individuals living outside the plume was 3.8 nanograms per liter. There were elevated PCE concentrations not only from residents living in the Superfund site, but also from those living in the other plumes outside the EPA Superfund site, as well as living outside any contaminated plume areas, indicating a broader range of exposure to the community beyond just the EPA site. Furthermore, there was a correlation of 0.77 between breath sites and indoor air samples collected in our pilot study. Large amounts of indoor air samples collected by the EPA, presented in the top graph on the slide, demonstrates a significant distribution of PCE exposure as indicated by the exhaled breath sample collected in our study, which is presented in the other graph. This correlation signifies the need for future studies to fully confirm the relationship between the PCE concentration in indoor air and exhaled breath of the residents. PCE, again, was not detected in any of the samples. While the residential tap waters from PCE are within the EPA drinking water standard, the ideal level of exposure, which is also the public health-based standard, is the EPA maximum contaminant level goal, which should be 0. Due to the severe consequences of prolonged exposure to the chemical, this contaminant level goal is 0. Studies indicate that there should be further follow-ups measuring the exposure levels among residents. The indoor air and exhaled breath results demonstrate that a number of residents are exposed to high levels of PCE, albeit the exposure level is low among most residents. When examining the next steps of the study, it should be noted that there are no standard methods or protocols for collecting exhaled breath samples. Creating a standardization of exhaled breath sample collection can lead to more reliable data. Furthermore, expanding the sample size for the exposure assessment can help expand the validity of these results. One area that can also be tested in the future is unfiltered private well water in the residences that have private wells, as they may have varying levels of PCE that could correlate to increased exposure. Examining these effects of PCE can also be undertaken, as measuring the symptoms of chronic PCE exposure, such as neurocognitive effects and lower IQ in children in Martinsville residents, can help confirm the impacts of the presence of this chemical, as well as highlighting the need for increased intervention. We acknowledge our field sampling coordinator and community partners, Ms. Deborah Corcoran, Mr. Tom Wallace, and Dr. Tim Adams. We also sincerely appreciate our participants for their participation and support to the project. This project is internally funded by Purdue. Here's our references. Thank you so much for listening, and I hope you have a great day.